In this video, we'll have a look at the process of determining a sample size for two-class presence-absence sampling plane using the two-class presence-absence number 1 calculator. The calculator in the two-class presence-absence number 2 tab is equivalent to this one, except that you can also specify the analytical unit amount as part of the calculation. Now, there are several areas as part of this calculator that we will have a look at, and as usual, cells that allow user input are shaded in orange. At the top here we have an area for specifying the sampling plane by providing values for the sample size and the acceptance number. The corresponding OC curve is then shown in the graph at the bottom. Then we have an area for calculating the probability of acceptance and rejection for a particular detection probability that you might be interested in, which is why we call it a point of interest. And lastly, there is an area for specifying a consumer's and producer's risk point. Let's now have a look at how we can develop a sampling plane from a purely statistical basis to meet a consumer's and producer's risk point. The first thing we need to decide is whether we can tolerate detecting the target organism in any of the analytical units. This means that the acceptance number C is either fixed at 0 or it could be increased if needed. Irrespective, we would start the process by letting C equal to 0. Next, we need to specify the consumer's risk point. This is done by providing a worst case detection probability, which is, remember, an estimate for the prevalence or the amount of contamination in the food. We also need to specify the corresponding probability of acceptance, or how frequently we would accept lots that are contaminated at such levels. For the consumer's risk point, the detection probability is typically large and the corresponding probability of acceptance is typically small. So let's say that we have values of 10% for the detection probability and 7.5% for the associated probability of acceptance. Now, this current sampling plane with n equals 5 and c equals 0 gives a probability of acceptance that is 59% at a detection probability of 10%, which is shown here in the actual. The value is shown in red because this plane does not meet our consumer's risk point, because the actual is greater than the 7.5% that we specified. And this can also be seen from the graph at the bottom, which shows that the OC curve is much higher at this particular detection probability than our consumer risk point. Now, we want this OC curve to fall somewhere below this consumer risk point. And to achieve this, we have to increase the sample size. By trial and error, we might increase the sample size to 10, 15, 20, 25, and you notice that at this point in time, the actual probability here has turned green because it's now less than the associated probability of acceptance specified as part of the consumer's risk point. In fact, this is the smallest sample size possible to meet this consumer's risk point, because if we change this to 24, we notice that the actual probability of acceptance increases to 8%, which is in turn higher than our desired probability of acceptance. So let's change this back to 25. Now, At this point you're basically finished, unless of course you say that the sample size you calculated is too large for practical reasons. If this is the case, you will have to relax your consumer's risk point. And you can do this either by increasing the analytical unit detection probability or increasing the probability of acceptance at this level, or in fact increasing both of these to relax the consumer's risk point into this direction. Now you might also look at this area at a very low detection probability, so when essentially there is very little contamination, and you might see if this is acceptable to you. In some cases you might actually find that you want higher or particular probability of acceptance at very low levels of the detection probability. And you can specify a producer's risk point to have a look at this. For example, if we pick 1% and a 90% probability of acceptance, then we see a producer's risk point showing up on the graph. The current sampling plan does not meet this particular producer's risk point because now the actual probability is less than the probability of acceptance, and we need it to be greater than. To change the OC curve, what we need to do is increase the acceptance number by 1, because that will shift the OC curve to the right, and we now see that the producer's risk point is met, but unfortunately the consumer's risk point is no longer met. So in turn we now have to increase the sample size to lower the curve, and we get to 40. We're getting very close, and at 41 it turns out that both are now met. It might happen that the producer's risk point at some stage is no longer met, and at this point you would have to increase the acceptance number to 2, and then in turn increase the sample size until both points are met. Of course, as before, you may need to revise either the consumer's or producer's risk point, or possibly both, to achieve a sampling plan that is actually practical.